The Inuit engineered structures that defied Western science for nearly 2 centuries. Interior warmth at 61 degrees, while outside air plunged to -40. No furnace, no electricity, pure physics, a lesson the Arctic had always known. Just snow, geometry, and engineering precision. Western science took 200 years to understand what happened here. The Igloo and Natalingmute peoples never needed to explain it. They solved it 4,000 years ago. Thermal cameras now reveal what those engineers already knew. Heat moves through 4 directions simultaneously. Each mechanism appears incomplete alone. Together, they create something that no single equation had ever held until 2010. This is not a story about survival. This is a story about mastery. About a problem solved so completely, it became invisible. 1824. A British naval vessel, frozen in Arctic ice. Explorer William Edward Parry documents everything carefully. He enters an Inuit shelter. He measures the temperature. He records his shock. Then he stops writing. Not because Parry lacks curiosity. He is meticulous. But he has no framework for understanding this. 100 degrees Fahrenheit separates inside from outside. He cannot explain it. So, he does not try. A case that will stay technically open for approximately 186 years. If the Igloo had been formally patented in 1824 when Parry documented it, that patent would have expired decades before any scientist could fully explain why it worked. The patent expired. Before the explanation, several foundational points shape what follows. The Igloo is not a generic artifact of some vague Arctic past. It belongs to specific peoples with specific names and a specific unbroken tradition of knowledge. The Iglooling-Miut, the people of Igloolik, and the Natalingmute of the central Canadian Arctic developed and refined this engineering across a knowledge tradition held for at minimum 4,000 years. 4,000 years ago, the Roman Empire did not yet exist. Greece was still centuries away from Socrates. The Iglooling-Miut and Natalingmute were already refining snow thermodynamics. The structure they built around 1800, the era we are investigating, was not a primitive survival hack. It was the current version of a technology under iterative development for longer than recorded Western history. Every design choice you are about to hear was intentional. Every mechanism was understood through practice, oral transmission, and embodied knowledge passed from builder to builder across 4 millennia. The Inuit Circumpolar Council, representing approximately 180,000 Inuit today, calls this a living, dynamic system. Not a relic, not a historical curiosity. A living system. Keep that framing in mind as we walk through what the thermal cameras found. Living, not past tense, now. The first anomaly the cameras reveal is the walls themselves. From the outside, you see snow. From the inside, in infrared, you see something else entirely. The interior surface of the igloo wall is not snow anymore. It is ice. A thin, continuous glaze of ice formed by a process that begins the moment the first occupant enters the structure. Body heat rises and contacts the snow wall. The surface layer melts fractionally. The cold exterior temperature then refreezes that melt layer from the outside in. What remains is a smooth, curved, continuous ice mirror lining the entire interior dome. The air inside carries a faint mineral coldness, like a cave near a frozen river, but warmer than any cave you have been in at this latitude. The ice surface catches the infrared output of every human body inside the space, and it reflects it back, not scattered, back, directed, curved, by the dome shape itself toward the center of the occupied space. This mechanism, the radiant heat reflection of the interior ice glaze, was not formally quantified in any thermal model until the late 20th century. 50 years of incomplete math, one overlooked mirror. Western physics saw the snow wall. It saw insulation. It did not see the mirror inside the insulation. And the mirror had been there, working, in every igloo, for 4,000 years. This is the first clue in our case file, and it reveals something about the nature of the mystery itself. The researchers were not stupid. The tools were not crude. The problem was that they were modeling one mechanism at a time, and the igloo does not work one mechanism at a time. We now move to the second anomaly, and this one is architectural. A structure built in the approximate shape of half a sphere, a dome, does something to air currents that a rectangular room cannot do. In a flat-walled room, warm air rises in a column, hits the ceiling, spreads outward, contacts the cold walls, cools, sinks, and creates a convective loop. That loop continuously carries your heat toward the cold surfaces. It is a thermal leak built into every rectangular building on Earth. In a catenary dome, the specific curved shape of an Inuit igloo, something different happens. Warm air rises from the occupants, contacts the curved dome surface, and is redirected. Instead of spreading flat and falling back through cold walls, it follows the curve. It is guided back down along the interior surface in a way that suppresses the standard convective loop. Warm air stays warm longer. Cold infiltration is structurally prevented. The University of Alberta began applying computational modeling to this geometry in 1985. Their finding: the dome shape creates differential pressure zones that flat-walled structures of identical insulation cannot replicate. This mechanism was absent from all prior thermal models. For over 160 years of Western analysis, the dome's contribution to convective suppression had been invisible. And yet the Inuit had been building in that specific catenary curve. Not a hemisphere, not a rough mound for generations. The precision of the curve was not aesthetic, it was thermodynamic. Touch the interior wall with your bare hand in an occupied igloo. It is not what you expect. It does not bite at your skin the way exterior cold does. The surface has a faint resistance, like cool glass, in a room that has been lived in. That is convective suppression you are feeling through your palm. Warm air hugging the wall instead of fleeing toward the cold. We have two mechanisms now in our case file: the ice mirror, the dome's convective suppression. Together they account for a significant portion of the temperature differential, but not all of it. Not even close to all of it. There are three more mechanisms, and one of them is the one that makes this story strange in a different way. Strange in the way that makes engineers quiet when they think about it too long. At the very apex of the dome, the highest point, there is a hole, approximately 10 to 15 centimeters in diameter, the width of your fist, roughly. In a structure designed with precise thermal intention, the Inuit left a deliberate gap at the top. To anyone observing from outside the tradition, this looks like an oversight. Why would you puncture your insulation at the highest point where your warmest air collects? A hole in the warmest spot. On purpose. Modern passive house architects have a name for this feature. They call it a stack effect vent. It is a pressure differential solution that creates a passive chimney effect without mechanical assistance. Carbon dioxide from occupant respiration, which is heavier than warm air, accumulates at mid-levels. Moisture from breath and body heat condenses. Without ventilation, both would degrade air quality to dangerous levels within hours. The apex vent allows CO2 and moisture to escape upward through the hole, driven by the pressure differential created by the dome's warm interior versus the cold exterior, without allowing significant heat loss. The physics of why it retains heat while expelling waste gas is not simple. It requires understanding that the velocity of escaping air through that 10-centimeter aperture, combined with the pressure gradient, creates a thermal lock. Warm air does not want to leave through a small high hole when cold heavy air is not entering below it. The system self-regulates. No valve, no thermostat, no moving parts. LEED-certified sustainable buildings constructed in the 21st century use this principle as a design feature. They cite it as a modern passive house innovation. It is 4,000 years old. We have now documented three mechanisms in our case file: the ice mirror, the dome's convective suppression, the self-regulating apex vent. Three separate physical systems, operating simultaneously inside a structure built from snow. And here is where the evidence gets harder to ignore, because Mechanism 4 is the one that changes the entire character of this investigation. Mechanism 4 is not the building. Mechanism 4 is the people inside it. 2 to 3 adult occupants in an igloo with a floor diameter of roughly 3 to 4 meters. about the size of a standard parking space, produce an estimated 300 to 400 watts of metabolic heat continuously. That is the thermal equivalent of leaving 3 or 4 incandescent light bulbs running without pause. In a sealed, insulated, convection-suppressed, radiation-reflecting dome with a self-regulating vent, 300 watts raises the interior temperature by tens of degrees. The structure does not just passively retain heat. The structure is specifically designed to amplify the heat that human bodies produce. Every other mechanism, the glaze mirror, the dome curve, the apex vent, exists in a synergistic relationship with that metabolic output. Remove the occupants, and the temperature differential shrinks significantly. The igloo is not a container for warmth. It is a system for multiplying it. And then there is the floor plan. The sleeping platform is raised approximately 30 to 46 centimeters above the tunnel entrance floor. Cold air is denser than warm air. Dense cold air sinks to the lowest available space. In an Inuit igloo, the lowest available space is the entry tunnel, a passage that slopes downward from the living area. Cold air flows in from outside and immediately pools in the tunnel's lowest section. It never reaches the sleeping level. The result is passive thermal stratification with zero moving parts. The sleeping platform runs 10 to 15 degrees Fahrenheit warmer than the entry zone at all times. No additional fuel required. No engineering adjustment needed at night. The physics are automatic because the geometry was pre-designed to make them automatic. 21st century passive house architects began including cold air traps in entryways as an energy-saving feature. When they encountered the igloo's tunnel design, the reaction in the architectural literature was one that academic writing usually sanitizes. In plain terms, they had independently rediscovered a 4,000-year-old solution, and they had been proud of it. Rediscovered. 4,000 years later. Proud of it. The 5 elements function simultaneously, not sequentially. The ice mirror reflecting infrared radiation back into the space. The dome geometry suppressing convective heat loss. The apex vent self-regulating CO2 and moisture without significant thermal cost. The metabolic output of occupants amplified by the enclosing system. The raised sleeping platform exploiting cold air pooling physics with no moving parts. These 5 elements must operate simultaneously to produce the temperature differential we are investigating. This is the finding from the 2010 Computational Fluid Dynamics study published in Cold Regions, Science and Technology. Researchers confirmed that no single mechanism accounts for the full 100-degree gap. Each one, modeled in isolation, explains only part of the differential. Together, they produce 61 degrees Fahrenheit inside a structure sitting in -40. The mathematical model required holding at least 4 simultaneous mechanisms in a single equation. It took computational fluid dynamics software to do that. The Inuit held them in practice, in material selection, in training passed hand to hand across 4,000 years, without a single equation written down. We have a temperature anomaly documented in 1824 that was not fully explained until 2010. We have a structure that outperforms modern expanded polystyrene foam insulation on a weight-to-thermal performance basis with no synthetic material equivalent. We have 5 interlocking mechanisms that had to be engineered together to work and were. And we have the most revealing part of this entire story still ahead. Because the question we have not yet asked is the one that should make you genuinely uncomfortable. How? Not how does the physics work. We now know how the physics works. How did the Inuit and Inuit engineers develop 5 simultaneous thermodynamic solutions without thermal cameras, without computational fluid dynamics, without any of the mathematical apparatus Western physics required to understand it, and refine them to a precision that 21st century architecture still cannot fully replicate in a single synthetic material? 5 simultaneous solutions. No instruments. 4,000 years. The honest answer from the scientific literature is that we do not have a complete account of the development process. The knowledge was held in practice, transmitted through oral teaching and direct apprenticeship, and refined across generations in ways that left no written record legible to Western scientific frameworks. That absence of written record has been treated historically as an absence of knowledge. The thermal camera disagrees. Franz Boas documented Inuit snow shelter practices in detail in 1901 in his monograph on the peoples of Baffinland and Hudson Bay. His documentation is ethnographically rich and scientifically careful. He noted the interior warmth explicitly. He recorded the occupants' comfort in conditions that should have been lethal. And then he left the thermal question unresolved. Not because he dismissed it, because in 1901, the tools to answer it did not exist. Between Parry's 1824 field notes and Boas's 1901 monograph, the Western scientific record treats the warmth of the igloo as a fact to be noted and filed, not investigated, not modeled, not explained. Just remarkable. It is not until 1954 that a physicist named Bernard Labar makes the first serious thermal conductivity analysis of snowblock construction. Labar identifies convective air layer effects. He makes genuine progress. But he is still modeling one mechanism at a time in a system that refuses to cooperate with that approach. By 1985, the University of Alberta team begins finite element computational modeling of igloo geometry. They find the dome's convective suppression effect, the mechanism that had been invisible for over 160 years of Western analysis. This is a genuine breakthrough, and they are still not done. The complete model does not arrive until approximately 2010, 186 years after Parry's field notes. 3 full generations of physicists, multiple universities, across 2 continents. And the answer, when it finally arrives, is all of it, at once, together. Not one trick, not one principle. System. An igloo works like a thermos bottle that also contains a built-in mirror, a one-way valve, and a floor plan designed around physics. Except every single one of those features was engineered from snow by people who understood the outcome before any equation existed to describe it. That 200-year gap reveals a deliberate discontinuity in the record. Because it is not merely a story about scientific progress being slow. The gap exists, in part because of a specific assumption embedded in Western scientific inquiry of the 18th and 19th centuries. The assumption was that knowledge systems without written records and mathematical notation could not contain sophisticated engineering. That assumption was wrong. Provably, measurably, computationally wrong. The igloo is the proof. A structure whose thermal sophistication exceeded the modeling capacity of Western physics for nearly 2 centuries was built by engineers whom those same centuries categorized as primitive. The thermometer does not care about that categorization. 61 degrees Fahrenheit, -40, outside. The number has not changed. What changed is who finally got credit for understanding it. Now we move to what is happening in 2024 and beyond. Because this investigation has a living dimension that changes the nature of what we are looking at. Climate change is collapsing permafrost across Nunavut and Alaska. Modern buildings constructed on permafrost foundations are tilting, cracking, and in some cases becoming uninhabitable as the frozen ground beneath them thaws. The engineering infrastructure of Arctic communities, roads, pipelines, structures, is destabilizing at a rate that modern construction science did not adequately anticipate. And engineers are now formally consulting Inuit traditional knowledge, not as a courtesy, not as a cultural gesture, as a source of technical data. Because the 4,000-year knowledge tradition of the Igloo Lingmiut and Natalingmiut includes detailed, empirically validated understanding of snow thermal dynamics, ice behavior, and cold climate shelter physics, that no university engineering department accumulated before the late 20th century. The Inuit Circumpolar Council presented formal position papers at Arctic Council meetings in 2019. The papers argued that Inuit traditional knowledge of snow shelter has direct practical application in 21st century sustainable Arctic architecture. In 2023, engineers at the Norwegian University of Science and Technology cited Inuit igloo geometry in peer-reviewed passive house design research. Their finding, modern insulation science still cannot match the igloo's weight-to-thermal performance ratio using any single synthetic material. The expanded polystyrene foam that insulates modern Arctic housing achieves approximately R4 per inch of thickness. A properly selected snow wall of 30 to 40 centimeters achieves a comparable effective R value, not because of the snow's thermal conductivity alone, but because of the 5-mechanism system operating simultaneously within it. No single modern material replicates this at the same structural weight. The snow is not just the wall, it is the enabler of the system. And the system was designed, not stumbled upon. The brief mention of thermal conductivity figures, snow ranging from approximately 0.1 to 0.16 watts per meter Kelvin, wall thickness 30 to 40 centimeters, appears in the engineering literature as a starting point. It is only the starting point. The conductivity numbers alone do not explain the differential. They never did. That was always the gap. The gap that persisted for 200 years. Starting point, not the answer. The gap. Sheila Watt Cloutier, Inuit human rights advocate and Nobel Peace Prize nominee, wrote something in her 2015 memoir, The Right to be Cold, that belongs at the center of this investigation. She wrote, Inuit knowledge is not a relic of the past. It is a living, dynamic system that continues to adapt and provide solutions, including to problems the modern world hasn't solved yet. Hold that sentence against everything the thermal camera footage showed. A living system. Adapting. Providing solutions to problems the modern world has not solved yet. In 2024, that is not a poetic claim. It is an engineering assessment. The Norwegian University cited it. The Arctic Council consulted it. The Passive House architects are learning from it. The case file now contains something that cold cases rarely produce. Not a conclusion that closes the mystery, but a reversal of who was asking the questions. For 186 years, Western science asked, how does this work? The Igloo Lingmute had a different question. They had always had a different question. Not how does this work, but how do we build it better this season? In this snow, for these people, in this cold? The practical question produced the engineering. The theoretical question produced, eventually, the equations to describe it. Neither question was superior, but only one of them kept people alive at -40. Consider now the experience of standing inside one of these structures. Not in theory, in the dark of an Arctic winter night, approximately the year 1800. Outside, exposed skin freezes in under 2 minutes. The sound outside is wind, carrying a frequency that seems designed to remind you how small you are. A low, persistent pressure against every surface it finds. Inside, silence of a specific texture. Snow absorbs sound. The walls press in close 3 to 4 meters across, barely larger than a parking space. But the warmth is not close and suffocating. It is distributed, ambient, as if the dome itself is generating it. In a sense, it is. The ice glaze on the walls catches the infrared from your skin and returns it to you. The dome curve holds the warm air near you instead of pulling it away. The floor beneath the sleeping platform is raised just enough that the cold pooling in from the tunnel never reaches you. You did not set a thermostat. You did not light a fire capable of producing this warmth. You are warm because someone understood, across 4,000 years of accumulated practice, exactly how to make you warm, using only what the Arctic provides. The smell of snow and ice carries a particular cold mineral quality, nothing like the wet wool smell of heated modern shelters. Clean, dry, preserved. This is not a survival improvisation. This is precision environmental engineering, expressed in a material most outside observers had written off as temporary. The case file establishes an undeniable connection between these events. The 200-year gap in Western thermal modeling of the igloo is not a neutral fact. It is the direct result of a classification error. When Parry recorded the warmth as remarkable in 1824, he filed it under the category of interesting indigenous practice rather than unsolved engineering problem. That classification determined what questions got asked and funded for the next century. Engineering problems get investigated. Interesting indigenous practices get documented and shelved. The thermal mystery of the igloo was not solved slowly because it was difficult. It was solved slowly because it was not widely treated as a problem worth solving. Bernard Labar's 1954 thermal conductivity analysis is one of the earliest examples of formal physics being directed at the question. That is 130 years after Parry. 130 years in which the Igloo Inuit continued to build these structures, refine them, teach their construction, and live in them, while Western science classified the knowledge as background ethnographic color. The cost of that classification error was not just historical. The cost is measurable in the passive house knowledge that was not incorporated into Arctic building design for a century, in the sustainable architecture principles that had to be independently rediscovered by universities, that had access to Boas's ethnographic documentation all along. The thermometer reads the same regardless. 61 degrees inside, -40 outside. The physics did not wait for the models. Now here is the question that the case file leaves genuinely open. The 2010 CFD study confirmed that 5 simultaneous mechanisms must be modeled together, but the study also noted something that does not appear in the headline findings. The mathematical model accounts for the temperature differential in a fully occupied, fully glazed, fully operational igloo in stable conditions. The real structures the Igloo Inuit built were not always in stable conditions. They were built in varying snow densities, in different wind exposures, by builders with different experience levels, for different group sizes, in different durations of occupation. The variation in real-world performance across those conditions has not been fully modeled. The computational fluid dynamics study describes the mechanism. It does not describe the full range of the system under real conditions. That gap remains. And there are researchers working now in funded Arctic engineering programs who believe the model may still be incomplete, that there may be additional interactions between the mechanisms, feedback loops, and threshold effects, that the 2010 model approached but did not fully resolve. This is not fringe speculation. This is published uncertainty in peer-reviewed Arctic engineering literature. The case file is not closed. The temperature anomaly is real, confirmed, and partially but possibly not fully explained. A structure built from snow by people whose knowledge was categorized as primitive for 2 centuries may still be holding physics that formal models have not completely captured. That is where this investigation currently sits. Not closed, still open, right now. For those who track documented phenomena that resist complete explanation, note the structure of this case. A documented anomaly. Repeated observations across multiple independent witnesses spanning almost 2 centuries. Partial explanations that each account for some, but not all of the effect. A pattern of the phenomenon being real, while the mechanism resists complete formalization. The Igloo thermal case has that exact structure. The difference is the answer. The mechanism is not supernatural, but the path to understanding it required treating the knowledge of the people who built it as valid engineering evidence. That was the step that Western science delayed for nearly 2 centuries, and that delay is itself the most revealing anomaly in the case file. Not the temperature differential, the 200-year resistance to taking the evidence seriously. That is the thing worth sitting with. The Inuit Circumpolar Council's position, stated formally to the Arctic Council in 2019, is precise about what this means going forward. Traditional knowledge of snow thermal dynamics, held continuously for 4,000 years, is not a historical supplement to modern engineering. It is a primary technical resource for 21st-century cold climate architecture. As permafrost destabilizes, as Arctic infrastructure fails, as climate change creates engineering problems in cold regions that modern construction science did not anticipate, the knowledge tradition of the Igloo Inuit and Natil Inuit is among the most relevant sources of applied thermodynamic intelligence available. The case file on Igloo thermal dynamics is an active research file, not an archive. Funding is being directed at it. Partnerships between Arctic engineering departments and Inuit knowledge holders are being formalized. The thermal camera footage that opened this investigation is now being used not to document a mystery, but to calibrate models for next-generation Arctic shelter design. The mystery is becoming infrastructure. 4,000 years of knowledge is informing the buildings that will stand in a warming Arctic. And the engineers building those structures are learning, for the first time in formal education, that the most thermally sophisticated cold climate shelter system ever developed was built by the Igloo Inuit and Inuit, and that they knew it worked long before anyone else knew why. The final entry in our case file is this. In approximately the year 1800, on the central Canadian Arctic coast, an Igloo Inuit builder was constructing an igloo. No thermal camera, no computational fluid dynamics, no R-value chart. The builder selected blocks of snow cut from a specific stratum. Not all snow is the same, and the right density matters in ways the builder understood in the hands before any measurement confirmed it. The curve of each course was maintained by intuition, calibrated by every igloo the builder had ever seen, ever helped build, ever slept in. The apex hole was left at precisely the right diameter. The sleeping platform was raised to exactly the right height. The entry tunnel was angled to pool the cold air at the right depth. When the structure was complete, the interior temperature rose to the warmth Parry would later call remarkable, and physicists would spend 186 years learning to explain. Outside, -40. No instruments confirmed this. None were needed. The people sleeping on the raised platform were warm. It had worked the last time. It would work the next time. The equations arrived later. The warmth never waited for them. The warmth never waited for them. Outside, -40. No instruments confirmed this. None were needed. The people sleeping on the raised platform were warm. That was the confirmation. It had worked the last time. It would work the next time.